Okay, guys, as promised, I wanted to finish up this identity that we started in class today so that you'd have a chance of seeing a lot more tricks before you go into spring break and try the homework. So we got to the stage where at the bottom here we have the sine squared and a cosine squared, which we learned is equal to 1. So I'm going to just show that by saying this guy and this guy can be converted to 1. And then the other 2 sine x cosine x will remain untouched. And of course that's underneath sine squared minus cosine squared. So at this stage you take a look at what's on the left side over here and you compare it to where we're headed, which is the right side. And you look at the denominators, 1 plus 2 sine x cosine x, 1 plus 2 sine x cosine x. That's a really good indicator that we are very close to being finished. The only problem is the numerator is sine squared minus cosine squared, and up here we have 2 sine squared minus 1. So this cosine squared seems to be the guy that needs to go. So we are going to go back to one of our Pythag identities, where we know, of course, that sine squared plus cosine squared is equal to 1, but we can write cosine squared as 1 minus sine squared. And that's what we're going to use. We're going to use this cosine squared here, and we're going to replace it with 1 minus sine squared, but we're going to do it very carefully. And by that I mean when we have sine squared of x, and that's this guy, just rewritten, and we subtract cosine squared, I'm going to use parentheses to show that we have to get all of cosine squared subtracted. So in other words, 1 minus sine squared is being subtracted. So put a 1 minus a sine squared in parentheses, close those parentheses, and in the denom we still have our 1 plus 2 sine of x cosine of x, and you should see what's going to happen here. In the numerator, if we distribute the negative, we're going to have a minus 1, but this minus negative sine squared is going to become plus sine squared. And this sine squared and this sine squared is going to make 2 sine squareds. So I will go ahead and distribute the negative, and just so we don't lose ourselves here, and say sine squared minus 1 plus sine squared all over 1 plus 2 sine x cosine x. And then of course the last step is grouping our like terms, sine squared and sine squared, which are going to make 2 sine squareds, and 2 sine squareds minus a 1 all over 1 plus 2 sine x cosine x. And that, of course, is the same as what we had on the right side, which means we're finished. So that's a good test level question. A lot of conversions there, but really the key is recognizing this 1 plus 2 sine x cosine x came from this square of a binomial sine of x plus cosine x multiplied by itself. And we'll see this trick several more times throughout this chapter. Anyway, there you go, all finished. Enjoy your break, but definitely do try the homework problems that are posted on campus. Thanks.